Today we're going to learn about solving systems of equations using methods other than graphing. For example, substitution or elimination. The standard is MGSE 9-12.CED.3. Just a quick reminder, system of linear equations is when you have two or more linear equations with the same variable and you're trying to find, does it have a solution, meaning an XY solution, no solution, or infinity solutions. Here's an example of one solution. The lines intersect at one point. As you can tell on the graph, the solution here is 3, 3. Those two equations intersect at a point. That means those two linear equations have a solution. The lines are parallel. That means no solution. None at all. They never meet. They go forever and ever without ever touching. And then the lines coincide, infinity solutions. That means the equations are the same. They might not look like it when you first get started, but they are identical. And so they will be right on top of one another because the lines coincide. Okay, so we're going to start off by solving the system of equations graphically. To do this, you're going to need a TI-83 calculator. And I want you to go ahead and go to the y equals screen in the top left-hand corner. Okay? This is where your equation is going to go, but here's the deal. Both equations have to be in slope-intercept form. Remember, slope-intercept form is y equals mx plus b, where m is your slope, and b is equivalent to the y-intercept where it's hitting the y-axis. So let's look at the first example here. As you can tell, equation 2 is already in slope-intercept form, but equation 1 is not. So let's go ahead and convert 3x plus y equals negative 2 into slope-intercept form. So 3x plus y equals negative 2. To do this, all I want to do is get y on a side by itself. That way I can place it in my calculator, my graphing calculator, and solve. And y equals negative 3x minus 2. Once I have that, I'm going to place this equation and this equation into the calculator. So let's do that now. Y equals negative 3x minus 2 goes as y1. And then I'm going to make sure that when you're dealing with fractions, especially that half x right there, put that half, that 1 divided by 2 in parentheses, then place the x beside it, and then go plus 5. Then click graph. As you can tell, those lines intersect, so that means there is one solution. The easiest way on a graphing calculator to find the solution is click second graph, and you will have a table. So now let's scroll down through there and let's find our answer. Our answer to that equation is where the two y1 and y2 are the same. In this problem, this graph intersects at negative 2, 4. And here's an example of the graph. Okay, example 2. Once again, this equation here is already in slope-intercept form. But that first equation is not. So I'm going to place 4x plus 2y equals 8. I'm going to convert that into slope-intercept form. And a quick reminder, slope-intercept form is y equals mx plus b. So 4x plus 2y equals 8. So the first thing I'm going to do here is move the 4x to the other side using subtraction. And I'm going to rewrite 2y equals negative 4x plus 8. Now you don't have to put the negative 4x first. I just like to because that lines up with the y equals mx plus b. Now, the 2 is right beside the y, and we think to ourselves, what operation will separate the 2 and the y? Well, the inverse operation of multiplication is division. So we're going to divide 2 to both sides. And the number one mistake I see here, folks, is not distributing that 2 to both terms in that problem. Make sure you're giving the 2 to the negative 4 and the 8. y equals negative 4 divided by 2 is negative 2x. 8 divided by 2 is 4. And I end up getting negative 2x plus 4. Now, before we even put this in the calculator, what do you notice? The slopes are the same and the constants are not. So let's place that in the calculator and see what we get. Negative 2x plus 4. Negative 2x minus 1. The rule is, as you can tell, when the slopes are the same, but the constants are different, that is going to be a no solution. So this answer to this problem is no solution. Okay, now I'm finished with graphing. We are now going to get into the elimination method. You can also solve a system of linear equations using the elimination method. In this method, you add or subtract the two equations to eliminate one of the variables. Example 1. The first equation is 5x plus 4y equals 7, and the second equation is x plus 4y equals negative 5. Okay, first thing you're going to look at is which variable can I get rid of? In this problem, I'm going to get rid of the y, and the reason why is this. They both have the same coefficient. The coefficients for y's are both 4. So since both equations contain 4y, I'm going to subtract the equations to eliminate the y. And here's the rule. If the signs are the same, subtract. If the signs are different, for example, if that was negative 4y and positive 4y, I would add the two equations together to cancel out the y. So let's do that. 5x plus 4y equals 7. X plus 4y equals negative 5. So I'm going to subtract the two equations from one another. 5x minus x is 4x. 4y minus 4y cancels out. And then 7 minus negative 5 gives me positive 12. So now I've eliminated the y, and now I can solve for x. I divide 4 to both sides, and I get x equals 3. But I'm not finished. I've solved for x, and I'm going to place that up here. X equals 3. Now that I've solved for x, I am now going to substitute the value of x into one of the original equations. If it were me, I would pick the second one because I don't have to do anything with it. I just plug in x is 3. So 3 plus 4y equals negative 5. Subtract 3 to both sides. Negative 5 minus negative 3. I'm sorry, negative 5 minus 3, excuse me. I get 4y equals negative 8. Divide by 4. And y equals negative 2. So my answer to this problem is going to be 3, negative 2. Now, here is the cool thing about solving systems of equations. Since this is the x and this is the y, I can pick an equation, and if I did my math correctly, I can plug this in and see if the left side is equivalent to the right side. So let's try that. I'm going to go x plus 4y equals negative 5, and I get 3 plus 4 times negative 2 equals negative 5. 4 times negative 2 is negative 8, so I have 3 minus 8 equals negative 5. 3 minus 8 is equivalent to negative 5, so negative 5 equals negative 5. Since both sides are equivalent to one another, I did something right, and my solution is 3, negative 2. This is where the two equations would meet on the coordinate plane. Okay, now, for some systems, you may need to multiply one or both equations by a number or numbers to get the coefficient of one variable in both equations to be the same number with opposite signs. For example, 6 and negative 6. Okay, as you can tell, I've got two problems here. I've got 6x plus 3y equals 14 and 3x plus 2y equals 10. But here's the problem. None of my coefficients are the same. And to do the elimination method, I need it to where my coefficients are the same. So first step, choose a variable. You can choose x or y. In this case, I'm going to choose y, and here's the reason why. I don't have to do anything to the 6 because I can multiply the 3 by 2, and it's going to turn to be 6 as well. So that first equation, I don't have to do anything to, but I have to multiply this second equation by 2 to get that 3x to be 6x. So I'm going to do that now. I'm going to distribute 2 to 3x plus 2y equals 10. And I get 6x plus 4y equals 20. Now that my coefficients are the same, I can now solve by using elimination. Both 6's are positive, so I'm going to subtract the two equations. So I'm going to write the new equation, the old equation, the first one, underneath my new equation. So 6x plus 3y equals 14. Subtract the 2. The 6x's cancel out. That was our main goal anyway, to get rid of the x's. 4y minus 3y is going to be y. And 20 minus 14 is 6. So the y value for this problem is y equals 6. Now that I have y, I can choose either equation and plug it in to solve. I'm going to go with the first equation. 6x plus 3y, so 3 times 6 equals 14. 6x plus 18 equals 14. 14 minus 18 is going to be negative 4. So I have 6x equals negative 4. And I'm going to divide 6 to both sides. Yes, I'm going to get a fraction. And I'm going to go ahead and simplify that. And x is going to equal negative 2/3. Now here's example 3. This will be my last one for elimination. I'm going to get rid of the y's. I can do this by subtraction. Guess what? Everything cancels out, and I have 0 equals 1. If the variables cancel out and both sides are not equivalent, that means no solution. Now the substitution method. And what I found over the years, there is one method that you will truly love and one method you will truly hate. I like both, but I've been doing it a lot longer than you have. But when I was your age, my favorite was substitution. Because it's so easy, because it feels like what you did in 6th grade with solutions of equations where you're just plugging in the variable. And that's essentially what you're doing here. So one method you can use is called the substitution method. In this method, you replace one variable with an expression that is equivalent to the other variable. This creates a one variable equation that you can solve to find the value of the other value. Okay, for example, I have y equals 2x minus 1 and 2x plus 2y equals 10. As you can tell, my first equation here, y is by itself. It's in slope-intercept form. So I can just plug in 2x minus 1 as y because it says y equals 2x minus 1. So since y equals this, I can plug it in as y. So this is what this means. 2x plus 2. Now I'm going to put parentheses here because I'm substituting as y. So that y is gone. Because in the first equation it says y equals 2x minus 1. So I'm going to plug in 2x minus 1 as y, and all of that equals 10. Now, once I do that, I distribute the coefficient to the parentheses, and then I rewrite 2x plus 4x minus 2 equals 10. I now combine like terms. My two like terms are 2x and 4x, and I get 6x minus 2 equals 10. And now I solve the two-step equation. I solve that by adding 2 to both sides. And I get 6x equals 12. And now I solve for x. And x equals 2. So in this problem, x equals 2. Now, once you get that, I'm going to choose the first equation because x is on a side by itself, and it should be really easy to do. So y equals 2 times 2 minus 1. Y equals 4 minus 1. Y equals 3. So our answer, the answer to this system of equation is 2, 3. Let's look at number 1. I skipped over the last slide, so if you want to go over that example, you can pause the video. On this one, I'm going to look at number 1. When you have a problem like this, it is as easy as it looks. Y equals 2. So all you have to do is go 2x plus 8 times 2, and I'm going to put that in parentheses just so we know we want to do that first, equals 20. 2x plus 16 equals 20. Subtract 16 to both sides. I get 2x equals 4. Solve for x. X equals 2. So your answer is 2, 2, because y was already done for you. When you have a problem like that, that's like a gimme problem. You want those problems.